All right, now we're going to go ahead and talk about rational exponents. Again, kind of fractional exponents, negative exponents, that kind of deal. So a lot of you probably know that if you have a negative exponent, you just basically put it on the bottom or top, you flip it, it kind of reciprocates it, right? I'm not entirely sure if you know why, or frankly, if you care to know why, but I'm going to show you real quick. It shouldn't take too long, and it's really important, I think, to know the reason behind these. So I'm just going to list out some exponents here. Now, one of these that is just almost by definition, and if you look up on Wikipedia, there's actually some interesting conversation about it, is the a to the 0, and that's just 1, okay? But we do know that the way exponents work is if I want to go from a to the 0 to a to the first, I have to multiply by a, right? So a times, or 1 times a gives me a to the first. A to the first times a is going to give me a squared, and so on and so forth, okay? Well, what we're going to do now is, how would I work backwards with that, right? So if I wanted to get from a to the third to a squared, I could divide by a. Or I could multiply by 1 over a is another way of looking at it, right? And if I do that again, times 1 over a, then I get to a to the first, and I keep going. So now I do it again, and that gets me to 1 over a. And then I do it again, and I get 1 over a squared. Do it again, and I'm going to get 1 over a cubed. And that's a real easy way to see the relationship between these negative exponents. And I got a little jumbled. Hopefully you were able to follow along there. But yeah. All right, now let's look at another one. Let's look at when we have something like this, a to the 1 over n. Now, I'm just going to let you know, and I could do a similar example, but I don't think it's going to be as useful here. A to the 1 over n is the same as taking the nth root. And in fact, I usually find it easier to look at it as a to the 1 over n than I do the nth root, except maybe with the square root, okay? At least when I'm doing calculations. So what's an example of this? Let's say I had something like this, 8 to the 1/3 power. Well, that really just means the third root of 8, which we know is equal to 2, okay? Where this becomes important is when we start combining together some of these things. So let's say I had something like this. Well, I could rewrite this two different ways. I could rewrite it as a to the 1/3 squared, right? And I can do that because I know that 2 times 1/3 is equal to 2/3. So I get back to here using my exponent rule. Or I could rewrite it as 8 squared to the 1/3 power. Both are correct. However, if possible, getting smaller first is going to be easier because in the first example, I'm going to have 2, because 8 to the 1/3, or the third root of 8 is just 2, squared, which equals 4, right? But in the second example, I'm going to have 64 to the 1/3 power, and then I have to try to remember the fact that 64, okay, is just 4 cubed, so I get 4. Same answer, it works both ways, but we can decide which one makes the most sense for the numbers we are working with.